I'm super excited to announce that today we're bringing Bluetooth to Goliath. In the very beginning of Goliath, we've been thinking about Bluetooth. If you look at the numbers of IoT chipset sales, the number of Bluetooth radios for IoT basically equal the number of Wi-Fi and cellular devices. And so that means engineers who are building those products need tools that help them connect those devices to build their end products for customers. But it's the same problem of they have to go figure out all those pieces. And we weren't able to tackle that in year one when we're first building out OTA, for example. But fast forward to now where we have things like rock solid OTA for large fleets and cohorts, pipelines, the ability to do OTA for not just software but also AI models. And it took us to this point to be able to now go and tackle the next part of the problem.
Bringing a Bluetooth device onto the Goliath platform should be as easy, or in some cases easier, than a cellular or Wi-Fi or Ethernet device that you've already used with the platform. And folks that are generally familiar with Bluetooth in general should have a pretty easy time. There's effectively a number of servicing characteristics that we expose that facilitates pouch communication. But for the most part, it's very much a read-write kind of API on the Bluetooth device side. And so folks that have, ever exposed information or commands over a Bluetooth connection should feel very at home using Pouch.
We're a medical device design consulting firm. So we have clients big and small come to us. We do a little bit of commercial design also, but mostly medical. Most of the products that we develop need to be connected in some form or another. So we have a lot of wearable devices that we do that the patients would keep on them for days at a time, weeks at a time. And we need a way to offload that data to a mobile app, back-end cloud for further analysis, for alerting the user of anything that's going on. So Bluetooth fits in really well, especially with low power wearables. So Goliath works a little bit differently from how we normally do Bluetooth. A lot of times the Bluetooth paradigm is going to be sort of an always connected approach. Your device advertises when it's not connected and says, hey, I'm here, you can connect to me. The mobile app or the utility or something else connects to the device and then stays connected, right? So then you get a little bit, good latency. You need to send a command, you get a response. With Goliath Pouch, the device only sends and advertises necessarily when it needs to send data. So you can gain an enormous power savings in that you're not always advertising. And for very, very low power devices where you're talking, singular microamps into like the nanoamp range, you don't want to be advertising very often or very fast. So Goliath provides this ability just to shift around your advertisement rate depending on what you're doing. So if you don't have any data to send, you don't necessarily need to advertise. You just maybe need to check in every few minutes for like a message from Goliath. So that proves to be an incredibly good power savings tool in that you can completely shut, if you're not doing anything, just taking samples every 5 minutes, you can shut the device down completely. Whereas if you have like an always connected approach, you couldn't necessarily do that. But with like the Pouch gateway, all those messages that you're going to send from Goliath to the device are automatically buffered, put in order, and then the device receives them when it's ready for them. So you're talking when you're not advertising, device is shut down in the nanoamp range. You wake up briefly to take your sample, advertise a little bit, the gateway connects, exchanges data, and then off you go. So you're looking at a relatively straightforward approach to getting singular microamps to nanoamp range of power consumption, which for a wearable device is great.
Let's talk about some new terms here since we're in a new domain. Pouch is Goliath's new innovation in the space of indirectly connected devices transmitting info up to the cloud through a standard gateway. Indirectly connected means just that. For today, that means Bluetooth, but in the future, that could also mean things like CAN, LoRa, or even serial. Directly connected devices are the ones we talk about all the time here at Goliath. Cellular devices, Wi-Fi devices, Ethernet devices, even thread-based devices. They all have IP addresses assigned to them, but we're just going to call them directly connected.
So Pouch is really at the core of everything that we've built here. And the key thing that you'll hear us talking about over and over again is the end-to-end encryption support. But we wanted that to look like to our existing services that it was coming over a typical connection. It wasn't passing through a gateway or potentially multiple gateways before it got to Goliath. And so there was a lot of cryptography work and security work on the cloud side that mirrored that work that we were doing on the device side to be able to do things like offline generation of keys for encryption for data coming up and down from the device to the cloud and back to the device. So there's a lot of changes that went in on that side as well.
Pouch's security mechanisms allow you to focus on the stuff that you want to be doing instead of getting stuck with all the security details that you have to get in place in order for your application to be secure. And we've tried to balance that with not putting too much of a burden on the application here to get this working. There's a low threshold for entry. It kind of just works. You push the certificate on there and you can start sending messages to the cloud. And I think that's important because security shouldn't be hard to do correctly. And we've tried really hard here to make it really easy to do security correctly with Pouch.
Encrypted Pouch data on a Bluetooth node like this one, it will pass through a gateway, but that data actually won't be seen if you're looking at the terminal output on the gateway itself. That's because it's encrypted with the cloud and the gateway actually doesn't have the keys. Gateways are directly connected devices and they have their own keys to the Goliath cloud. They pass along encrypted pouches from the indirectly connected devices. The idea of managed gateways that we're talking about here is all explained in our taxonomy of connected device networks over on our blog. On my bench, a gateway often looks like this. It's a dev board. It's the Freedom RW612, one of the many that is supported in our newly open source Bluetooth gateway repository. We have reference implementations that target a few different development boards, but we also announced support for off-the-shelf gateways today in our blog post. For those of you who need additional functionality, it's possible for you to take the reference implementation and build your own. That's what we did with our in-house development platform called the Aludel Elixir, and then we use this, which is a directly connected device, and it can send its own data in addition to sending data from a node.
So the interesting thing about gateways is they're just typical Goliath devices, right? They have a direct connection. You could actually imagine that every directly connected device on the Goliath platform, if the user so desired, could act as a gateway if it had, whatever the other protocol, Bluetooth or LoRa or what have you, enabled as well. And so really what we looked at was how do we take these directly connected devices and turn them into gateways? And then what other types of hardware would be acting as gateways as well? So I think the part that really kind of forced us to think holistically about it was smartphones and mobile applications, because those look a lot different than Goliath devices typically do. And they may not be managed actually by the product creator. They may be a user of the product that is allowing a connection to the cloud. And so we had to rethink some of our authentication schemes and also how we create permissions and roles on the cloud side to allow for, just gateways associated with a certain customer to proxy for their devices, and how they could allow their users, smartphones and things like that, to be able to proxy for those devices as well. And that created kind of an evolution of how we think about the concept of a device in general on the Goliath platform.
One of our design goals has been to make the gateway as dumb as possible, because basically all of the intelligence lives on the device and lives on the cloud, and the gateway just shuffles information back and forth. And a big part of the reason for that is so that the gateway doesn't need to be updated very often. I think there are reasons why specifically it should be the gateway that isn't updated very often. But generally, the goal here is so that you just take one less thing that you have to worry about, right? Like you have 3 different places where this protocol is running that have to coordinate. If we make the gateway really, really simple, it doesn't change that much. Now, when you make changes, you're only making it in 2 places instead of 3 places. Normally, when you're developing these protocols in-house, you have to work very closely with a mobile engineer or whoever is designing your gateway, as well as a cloud engineer, as a firmware engineer. I'm speaking as a firmware engineer because that's what I am. Right. So those 3 people need to coordinate very closely, right? Every little bit gets negotiated over. The timing of things, the whole thing has to be worked out. And the difficulty is not just that you're building it in 3 different places, but at larger companies, and the companies don't have to get that large for this, you have competing priorities.
It's greatly improved our development speed. So we no longer have that that hard dividing barrier where we make a change to, adding 10 different settings or something like that. We don't have to necessarily go to an app developer. We can just use like a Golioth gateway. The crucial part there is the lack of a dividing barrier now, right? So the source of truth lives on the device controls all of the communication, and it's an instant feedback process, right? So you want to add a setting, compile your firmware, flash it, and then boom, it's on Golioth. There's no back and forth, there's no waiting a day for responses, there's no needing to push an app, right, to go through that whole release process and things like that. You make a change, you can see the change, and then you can continue on with testing and iteration. Changes that are quick 5-minute changes, like, hey, we need this setting to, change the sample rate, right? Something like that. That goes in instantly, and then you're back to testing. You're talking 10 minutes. Or you need to send a new type of data packet. Maybe you add a metric, or maybe you change one of the data types of what you're streaming back from your sample data to a UN32 instead of UN16. So now with Golioth, that's a very easy process. Whereas with a hard line between the firmware and the app development, that becomes much more difficult, especially when you're talking about, we need to support this old style too, right, of a UN16, and maybe we're packing C structs or something like that. That becomes a versioning nightmare. And then that's not even taking into consideration, we need to support this older version for a little bit, but those have different settings, and that breaks when we start parsing things to send it down to the device.
So our vision is to be the universal connector for IoT, and Bluetooth devices are IoT devices that are pretty difficult to connect. And so as part of that mission, we want to be able to connect everything. And being able to bring what we've done for directly connected devices to Bluetooth now just expands what people can build with Golioth, but also new kinds of use cases. Bluetooth devices tend to be cheaper to manufacture. They have really good power profiles. And so certain business models that may not make sense with putting a cellular modem and everything might actually be realizable with a cellular gateway plus some of these nodes. And so we can see how this expands to unlock new companies and how they might approach building their connected products.